Another story, another take on the so-called truth. But how do we really know what the truth is? It might be easier to distinguish what is more or less true, but when it comes to academic sources, it becomes a little bit more confusing. Here, it might seem simple to say which magazine might be more objectively true and which one might have a more subjective take on matters. But not even here is it entirely easy to say. As you are all students of science of various sorts, my following question is, how do we distinguish between what is more or less true when it comes to these then? Or when it comes to this, or this? Being source critical isn't always that easy, but in order to become a master at it, along with ensuring that no one accuses you of plagiarizing, that is, copying what you've done from someone else, there are a few basic concepts you as a beginner student need to think about, and as well as being reminded of it as a more advanced student. Take this apple. This apple represents what we as scientists are interested in. And yes, you are scientists, no matter what anyone tells you, because already as starting out as a beginner student, you are a scientist. But this apple can be the world, the universe, a social phenomenon, a product, a process, an electrical circuit, you name it, attitude, feelings. Basically, what we're interested as scientists is how this affects us, or how it doesn't affect us, or anything in between, really. Every area of science has chosen a certain area to work within. Let's take a few examples. There are so many more disciplines being researched in different ways, and they're usually separated from each other in many different ways, but they also overlap, and it can be very confusing as a beginner student to know what belongs to your field of expertise and what doesn't. But what it basically boils down to is that every single discipline is concerned with our existence, what is, has, or will possibly affect it. Let's then take one discipline as our example. Within every discipline, there are usually a whole bunch of scientists or researchers who've dealt with several different types of apples within the limits of that discipline. But let's only take one particular apple as our focal point. First, there was probably the apple, and then along came a person who noticed that apple. Another person noticed the same thing about that kind of apple on the other side of the world, perhaps. And then yet another person saw something entirely different about that same apple. Step one was noticing the apple and its characteristics, and step two is deciding to do something about it. There's a great picture by Van Leer that shows a few things that you can decide to do to that apple as a scientist. Your imagination is, of course, the limit here. To make a very long story a bit shorter, the discipline usually has more or less accredited scientists, better or worse scientists, or good or better scientists. Those whose names you hear again and again throughout your education probably are a little bit more accredited, and they are probably, or might be, a bit closer to the truth. What science aspires to is to be the accumulated knowledge of the apple from as many angles as possible, from as many researchers as possible, who either agree or disagree, which brings all the more depth to the knowledge about the apple. I mean, if everyone says something is true, how would you know if it wasn't? If we then take one researcher who conducts an experiment on the apple, who reports his findings by comparing it with previous research on that same or similar apples, then take another researcher who reports and contrasts the findings of the researchers who've done experiments on red apples, then take a researcher who researches all of the research on any type of apple or situations where there probably should have been an apple. The further away from the apple you get, the more important it is to cite your sources correctly. Do you think that when and where and under what circumstances the apple or the literature about the apple was written is significant to your research? It probably is. Wine from grapes grown in Chile are not the same as grapes or wine made from grapes grown in Germany. This is due to the amount of sunshine, the amount and quality of rain, the quality of the soil, what kind of grapes have been grown, what type of methods have been used, planting, growing, harvesting, refining, and storing it, etc. All of these aspects also vary due to time, not only due to locations and methods used. So your discipline probably looks a bit like this. Where are you then in all of this? Right about here. And your teacher? Here, doing this. So what is then your task as a student researcher? And what does all of this have to do with plagiarism? Well, the concepts I've shown you should make plagiarism redundant. That is, it's simply not necessary, and quite beside the point of your studies anyhow. What your teachers want from you in the beginning is not to take on the apple and start experimenting or asking the apple questions, but rather for you to understand a part of the big picture, and then to show them what you have understood that to be. Perhaps the teacher wants you to be able to take 3 different views of an apple and evaluate how relevant or close to the truth they might be. Or just to find the researchers who've looked at red apples. Your task as a student is not to redo science or add to the science quite yet, but to get to know and to reflect upon the accumulated knowledge which is already there, collected by others. The need to plagiarize comes from students thinking, I don't have what it takes, which couldn't really be further from the truth. If you succeed in taking it a small step at a time and not trying to take on too much at one time, not having what it takes can include thoughts or feelings like, I'm not intelligent enough, or I don't have the time, and no one in my family is an academic. I don't have the stamina or the knowledge to do what is asked of me. You might even have inflated ideas about what the teacher actually demands of you that you've made up yourself or that your friends have made up. Teachers might not always be the best at telling you what they expect from you either. And academic language use can be quite difficult at times as well, which can make assignments sound more difficult than they really are. The teachers can also have too high expectations from you. So never hesitate to ask and critically reflect on your tasks and give appropriate feedback to your teachers about them. And never, I repeat, never hesitate to ask questions, no matter how dumb you feel they are. When regarding science, you can think of it as a football game. In order to be successful, you need to know your own team, as well as more slowly getting to know the players of the opposite team. You need to trust your own goalie or goalkeeper as the ball moves across the field and outside the field sometimes as well. You also need to prepare and have a bit of knowledge about adjoining fields or forested areas outside of the football arena, and hope that you get through the opposing goalkeeper into the opposing goal. And finally, you need to play by a set rule of the game. Most importantly, always keep your eye on the ball. That is yourself, and make sure that you know where you stand, and make sure that you're able to tell other people where you stand in the game. And finally, make sure that you're playing the right game. Playing or bowling when you're supposed to be playing football just makes it that much more difficult to succeed at what you're trying to do. This game lasts as long as you want it to, of course. It can be 3 years, 5 years, 10 years, the rest of your life. And the perfect game does not appear at once. Not in a year, but after many years in the game. And it's all about practicing in order to get there, failing miserably many times, is also a part of it. Hurting yourself, falling down, shooting at the wrong goal, failing to follow the rules, aiming too high or too low. As Edison said when asked about having failed 700 times before finally inventing the light bulb, Edison answered that, "I have not failed 700 times. I've not even failed once. I've succeeded in proving that none of these 700 ways will work. When I have eliminated the ways that will not work, I will find the way that will." When the time comes for you to sit down and report on your work, the teacher cannot really know where you have been within your own complex discipline and what of it you've understood, along with what you haven't understood. The easiest way of making the teacher aware of your progress or of your work is by using references correctly when completing the tasks. Regardless of which referencing system you use or your discipline prefers, they all boil down to one thing. And here you see the necessity of adding the year and date that particular researcher has said or written something. Remember that a good rule of thumb also is 5 years, if the material is older than 5 years, it's getting a little old. If it's getting older than 10 years, it's probably not even good to use it. If it's over 15 years, forget it, if it's not a really, really good source. By using the references correctly, you let everyone know who reads your text know where you've been, what you've read, who has come up with what ideas, and little by little, you as a student can get to know the apple, the researchers who are connected to that particular apple, and you can draw more and more conclusions yourself from what you find, or start with the apple yourself. The most important thing to remember is to not only use references when using direct quotes, but also when paraphrasing and using others' ideas, models, pictures, videos, theories, etc. The further on in the process you get, the more things you can say for yourself, but be warned. There are very little things in this world we can know for absolutely certain. So be careful how you say what you think. This might perhaps be a bit of a Finnish way to look at science, and particularly writing about science. There are also different views on the matter within your own discipline. Therefore, make sure that you know what your teachers expect of you. Within Bloom's cognitive taxonomy, there is something called the cognitive steps, from which you can ascertain how far you've gotten. Using correct references and referencing techniques is the key to avoiding being accused of plagiarism. That is, give credit where credit is due. In part 2 of this series, I'll show you some methods and tips, scholarly study techniques, if you will, when working with scholarly texts as students, regardless of what discipline you belong to, in order to make sure that you never, ever plagiarize, not even by mistake. Well, all this talk of apples has made me hungry. How's this for a scientific experiment?